Hello friends, in today's question, a lamina is made by removing a small disk of diameter 2r from a bigger disk of uniform mass density and radius 2r as shown in figure. The moment of inertia of this lamina about the axis passing through O and P is IO and IP respectively. Both these axes are perpendicular to the plane of the lamina. The ratio of IP to IO to the nearest integer is. So this is a bigger lamina, a bigger you can say disk, and from this bigger disk a smaller disk of diameter 2r is being removed, and we are supposed to find out the moment of inertia of the remaining lamina with respect to point O and with respect to point P. Okay. So from the question it is clear that the lamina which we are going to get will be bigger disk minus the smaller disk. So lamina is equal to bigger disk minus smaller disk. Then we have to find out the moment of inertia of the lamina with respect to point O as well as with respect to point P. So in the first part, we are given that moment of inertia of the lamina about point O, about the axis rather, about the axis perpendicular to the plane and through point O, through point O. So in this case we have a bigger disk and its center is given as O, and this is the axis which is perpendicular to this plane, minus we have a smaller disk, and this moment of inertia will be also with respect to point O. For the smaller disk, the point O is on the circumference, and here also it is perpendicular to the plane. The axis is perpendicular plane. Okay, so we already know that lamina is bigger disk minus smaller disk, so this will be giving us the lamina. So it means, and this is our IO. So IO is the moment of inertia of the bigger disk above point O minus the moment of inertia of the smaller disk with respect to point O. Okay, and this is the, let us suppose, center of the smaller disk which is given as C. In the second part, we have to find out IP, and IP is the moment of inertia of the lamina about the axis perpendicular to the plane and passing through point P, which is being called as IP. So IP will be moment of inertia of the bigger disk with respect to point P, and point P is on the circumference of the bigger disk. So this is point P, and this is the center of the bigger disk whose center is given as O, minus the moment of inertia of the smaller disk with respect to point P, and if this is a center of the bigger disk which is given as C, the P point will be somewhere here. So this is our P point, and this will be the distance between the perpendicular distance between the axis and here it will be distance between the perpendicular axis between the axis which is passing through O and P, and in this case this will be the perpendicular distance between the for the smaller disk, and this will be our lamina. So this is the basic understanding of the question which we are supposed to find out. So first of all, let's try to solve it for IO, that moment of inertia about point O, and we say, because it is given that it's a uniform mass density and it's a disk, so we'll say let the mass of bigger disk, is capital M, and mass of smaller disk is small m, and we are given that they have a uniform mass density. Okay. Therefore we can say mass density with respect to its area, we get m upon pi 2r square is equal to m upon pi r square for the bigger disk and as well as smaller disk, and pi and pi cancels out. So therefore from here we get m is equal to 4r square is equal to small m divided by r square. R and R goes away. Therefore we can say mass of the smaller disk is equal to mass of capital disk divided by 4. This relationship we are going to use later on in order to solve it. Now we take the first part. So we are going to find out moment of inertia of the bigger disk about this point O. Okay, and the axis is, in all the cases, the axis is perpendicular to the plane. So we can say for bigger disk, so this is our bigger disk, this is the center, and we have axis which is perpendicular to this plane and passing through the center O. So you can say moment of inertia about axis perpendicular to the plane and passing through point O. So we already know this formula because it is a standard formula. So let us write it as moment of inertia of the big disk about point O. This will be given as half its mass and radius square. Radius is given as 2r, so this radius is 2r. So let us substitute the value. We get half mass is equal to capital M and radius is our 2r, so we get 2r square, which will be equal to 2m r square. Now we are going to find out for the smaller disk. So first of all, we are going to find out for the smaller disk the moment of inertia about its center, which is given as c. Then we are going to use the parallel axis theorem and find out the moment of inertia of the smaller disk about this point O. For smaller disk, so this is our smaller disk, and with the center C, and its diameter is given as 2r, so its radius will be equal to r, and mass is small m. So we can say moment of inertia about the axis perpendicular to the plane and perpendicular to plane through point C, through center C, and let us say that for I small through center C will be equal to, once again, half mr square. Mass is represented as with small m, and radius here is r square, so this will be equal to half mr square. Now we are going to use theorem of parallel axis and find out the moment of inertia of the smaller disk with respect to point O. We already know through center C, so we are going to use theorem of parallel axis, and the distance between the parallel axis is r. So using theorem of parallel axis, moment of inertia about axis perpendicular to the plane through point O, and let us call this as I small through point O, which will be equal to I small through point C plus mass and distance between the two parallel axes. So I small we already know is half mr square, so we get this is half mr square. Mass is given as small m, and distance between is r, so this is r square. So we are going to get this as 3/2 mr square. So this is our I small, and I naught will be the difference between the moment of inertia of the bigger disk about point O minus the moment of inertia of the smaller disk about point O. This will be our I naught. So we can say moment of inertia of the lamina about axis perpendicular to the plane through point O. And which is given to us as I naught. So I naught will be equal to, we can say, moment of inertia of the lamina about point O, which will be equal to moment of inertia of the big with respect to point O minus moment of inertia of the disk which is small and through point O. Therefore, if we substitute the values, we get I naught big is given as 2 mr square minus small is given as 3/2 small m r square. We know the relationship between capital M and small m. We substitute it here. We get 2 m r square minus 3/2. This will be capital M divided by 4 and r square. So we get this as mr square, we can take it as common. So this will be mr square. This will be 2 minus, this will be our 3 by 8. So we get this as 13 by 8 mr square. So we got the value of I naught. Next, we are going to find out value of our IP. Okay, so IP is the moment of inertia of the bigger disk about point P, moment minus moment of inertia of the smaller disk also about point P. And we already know the moment of inertia of the bigger disk about point O. So we are going to use theorem of parallel axis and find out with respect to point P. So we can write this as moment of inertia of bigger disk about bigger disk about axis perpendicular to the plane passing through point P. So we're interested in, so this is a bigger disk. We already know the moment of inertia about the center, which is given as O, and we are interested in finding out moment of inertia about this point P. So we are going to use theorem of parallel axis. Okay. So we can say using theorem of parallel axis, and we can write it as moment of inertia of big disk about point P is equal to moment of inertia of big disk about point O plus the mass and the distance square. So distance is given as 2r. So big O is our 2mr square plus mass is capital M and distance is 2r square. So we get this as 2m r square plus this will be 4m r square. Therefore we get moment of inertia of the big disk about point P will be equal to 6m r square. Now we are going to find out moment of inertia of the smaller disk about an axis which is parallel to this axis passing through C and at point P. Once again, through C we already know, so we are going to use theorem of parallel axis and find out what will be the, you can say, the moment of inertia about point C for smaller disk. So you can say for smaller disk, so this is our smaller disk and this center is called at C, and we are interested in finding out for point P. So the point P is somewhere here, and this is the perpendicular distance between the two. So first of all, let's find out what will be CP, and we already know that, yeah, so let me draw it. So this is point C and this is point P, and we have center O. So this distance we also know, this distance is our R, and this distance between OP is 2R. So therefore we can say our CP will be coming as R square plus 2R whole square. please bear, this figure is not according to the scale. So let me redraw it again. This one will be coming like this, smaller disk. So we have this point as O and this as center C. Yeah, this is center C, and the point P is along this axis. Okay, there was some discrepancy in the figure. So this will be our perpendicular distance. This will be our CP. So we know this distance is of R because diameter of the smaller disk is 2R, and this distance is 2R because P is lying on the bigger disk. Okay. So we found out that the value of D is equal to R square plus 2R square and square root. So which we can write as R square plus 4R square and its square root. So we get distance D will be equal to R and multiply by square root of 5. So this is a distance between the C and axis passing through C and P. So we can say the moment of inertia for the smaller disk, moment of inertia of smaller disk about axis perpendicular passing through point P. So we are going to use theorem of parallel axis. Using theorem of parallel axis, we can say moment of inertia for small disk through point P will be equal to moment of inertia for the small through point C plus mass and the distance between the two axes. So I small c we already calculated, it is our half mr square plus mass is given as small m, d we just calculated is our r square root of 5 and whole square. So this we get as half mr square plus this will be 5 mr square. So we get moment of inertia of the small about point P is equal to, this will be coming as 7 upon 2 and mr square. Now we are going to find out moment of inertia for the lamina, and we already know that moment of inertia of the lamina about point P is given as IP, which will equal to moment of inertia of the bigger disk about point P minus moment of inertia of smaller disk about point P. So therefore we can say moment of inertia of lamina about point P will be equal to, which is given as IP, and IP will be equal to on the moment of inertia of lamina about point P, and axis is perpendicular to the plane. So therefore we can say moment of inertia of IP is given as, we can say moment of inertia of lamina about point P, which will be equal to moment of inertia of the big disk about point P minus moment of inertia for the small disk about point P. Therefore we can write that our IP is equal to bigger disk about point P is 6 mR square minus for smaller disk we just calculated it is our sorry, I made a mistake here. This will be coming as 11 by 2, not 7 by 2. This is equal to 11 by 2 mR square. I wrote 7 by 2. This will be equal to minus 11 by 2 and mR square. Now substituting the relation between small m and capital M, so this will be 6 mR square minus 11 by 2, and we get this capital M divided by 4, and we have R square. Therefore IP is equal to, we can take mR square as common, and this we get as 6 minus, this will be 11 upon 8, and we get this as mR square 48 minus 11 divided by 8. Therefore IP is equal to 37 upon 8 and mR square. So we found out what is our I naught as well as IP. Now we are supposed to find out what will be the ratio of IP and I naught. So we can say ratio of IP upon I naught is equal to 37 upon 8 mR square divided by, we got this as I naught is 13 by 8 mR square. This goes away, 8 and 8 cancels, so this will be about 37 upon 13. Therefore IP upon I naught is equal to 37 upon 13. So this is the ratio of lamina about point P and point O. And okay, it was a integer type question, so this is the complete answer. This completes the question. Thank you.